Hi guys. Okay, so today we're going to talk about synthetic division and the remainder theorem of polynomial functions. So I'm going to take you way back in time and we're going to divide 12,372 by 11. We're going to do long division just like you did in elementary school. Okay, so we're going to take 11 and it divides into 12,372. So now remember, when we do this, our divisor is the 11. That's what we're dividing by. Our dividend is what we're dividing into. That's the 12,372. So we're going to do the division to find the quotient and the remainder. So we'd say, okay, 11 goes into 12 one time. 1 times 11 is 11. And we subtract. We get 1. We bring down the 3. Now we say 11 goes into 13 one times, and 1 times 11 is still 11, and we subtract. 13 minus 11 is 2. Bring down the 7. Now 11 goes into 27 2 times. 2 times 11 is 22. We subtract, and we get 5. We bring down the 2. Now 11 goes into 52 4 times, and 4 times 11 is 44. When we subtract, we get 8. So when you first started doing division, you were allowed to say your answer was 1,124 remainder 8. That's because your quotient was 1,124 and your remainder was 8. But as you got older and more advanced, you realized that the better way to express this answer was 1,124 and 8/11ths, right? That was really the answer to the division problem, 1,124 and 8/11ths. Now, I want to take a moment here to talk about these mixed fractions. Remember, this 1,124 and this 8/11ths, they are being added, not multiplying. It is 1,124 and, which means add, 8/11ths. Okay, so that we are actually adding the quotient and the remainder over the divisor in order to get the value. Okay, so now we're going to move forward into algebra, and we want to do division of a polynomial by a binomial. So we have x cubed plus 6x squared plus 7x minus 6, and we want to divide by x plus 4. So the first method is long division, just like we did in the previous problem. Now when we do long division, you actually use the leading term to do the division. My divisor is written. My divisor was the x plus 4. My dividend is what I'm dividing into. Okay, now when we do this, we say, okay, we look at the leading terms, x and x cubed. How many times does x go into x cubed? Or x times what gives me x cubed? That would be x squared, right? Because x squared times x is x to the third. But I also have to do x squared times 4, which is 4x squared. Now remember, I'm subtracting this. But when I subtract, I change subtraction to addition and change the signs. So x cubed minus x cubed is 0, goes away. 6x squared minus 4x squared, there's 2x squared. Now bring down the plus 7x. So again, I'm going to use my leading terms, x and 2x squared. How many times does x go into 2x squared? That would be 2x. So again, 2x times x is 2x squared. 2x times 4 is plus 8x. And I am subtracting this, but remember, subtraction becomes addition. Change the signs of everything we're subtracting. The 2x squareds go away. 7x minus 8x is a negative x, and we bring down that minus 6. Okay, again, we use the leading coefficients. X times what will give us negative x? That's negative 1. So negative 1 times x is negative x. Negative 1 times 4 is negative 4. And remember, we're subtracting. Subtraction becomes addition. Change all the signs. The x's go away, and negative 6 plus 4 is negative 2. So it looks like we have x squared plus 2x minus 1 as our quotient, and a remainder of negative 2. Now, there is another method called synthetic division. Now, synthetic division, we remove the variables to make it a little easier to work with. We start with a half box. Now, in this half box, we say, okay, here's my divisor. What is the root of x plus 4? The root of that would be negative 4. So that's the number that goes in our box. Now, we're going to take the coefficients of our polynomials. Now, remember, if there's no number here, that's the invisible one. So I have 1x cubed, I have 6x squared, 7x's, and then my constant is negative 6. Okay? Now, we always bring down the first term. Now we multiply. Negative 4 times 1 is negative 4. Then we add. 6 and negative 4 is a positive 2. We multiply. Negative 4 times 2 is negative 8. Now we add. 7 and negative 8 is negative 1. Now we multiply. Negative 4 times negative 1 is positive 4. And then we add. Negative 6 plus 4 is negative 2. Now I always either circle or box my last number because that one is my remainder. And notice it is the same remainder we got using long division. Now, since we started our problem with an x cubed, our answer is going to be x squared. And these are the coefficients on our answer. Only we're going to be 1 degree lower. So we're, instead of x cubed, we're going to be x squared. So we have 1x squared plus 2x's plus a constant of negative 1. And look at that. That is the same quotient we got with long division plus our remainder over our divisor. Now, it's okay if you write your answer this way, or some people prefer, and I usually do this, I put the minus sign here and 2 over x plus 4, because really a negative in a fraction is not in the top or the bottom. It's usually in front of the fraction because it's negating the whole thing. Okay, and there we have our answer to the division by both long division and synthetic division. We get the same answer no matter which method we use. Okay, but one might be a little bit easier than the other. Now there is one more thing I want to do here. I'd like to find, and I'm going to come back to the reason why, but I'd like to find p of negative 4. Now notice p, that's the dividend. So we're going to put negative 4 into the dividend. That was the polynomial that we were dividing into. So what we have is we have negative 4 raised to the third plus 6 times negative 4 squared plus 7 times negative 4 minus 6. So that's going to be negative 64. Negative 4 squared is 16 times 6, that's 96. Then 7, that's going to be a negative 28 minus 6. And if we look, let's see, negative 64, that's negative 70, negative 98. So I have 96 minus 98, that's negative 2. Okay. Now, I want to make sure you're aware of the division algorithm. The division algorithm says that the polynomial is the divisor times the quotient plus the remainder. Now think about that if we had something like 15 divided by 7, okay? We know that if we put 7 into 15, it goes 2 times and we have a remainder of 1, right? So we know that the answer to the division is 2 1/7. Now according to the division algorithm, 15 would equal the divisor 7 times the quotient 2 plus the remainder 1. This is what the division algorithm says. And it's true, right? Because 7 times 2 is 14 plus 1. That is indeed the 15. Now let's try this for that same algebraic problem we just did here with the polynomial. So p of x, our original polynomial that we were dividing into, okay, p of x would be that x cubed plus 6x squared plus 7x minus 6 is going to be equal to our divisor we divided by x plus 4 times our quotient. That's the answer to the division without the remainder. That's the x squared plus 2x minus 1, and then plus the remainder, which in this case was a negative 2. This is what the division algorithm says. Okay, so sometimes you'll be asked to rewrite the polynomial according to the division algorithm. Now, there are some notes that I want you to be aware of when we're dealing with synthetic division. Okay, number 1, the degree of the quotient is equal, and this part doesn't matter whether it's synthetic division or long division, is equal to the degree of the dividend minus the degree of the divisor. Okay. The next note is that the degree of the remainder is less than the degree of the divisor. Because if it's not less than that, then the divisor goes in and can go in again, and you're not done. Now the third note, and this is an important one, for synthetic division, the leading coefficient of the divisor must be 1. That's important. If the leading coefficient is not 1, you can't do synthetic division until you make the leading coefficient 1. Okay, let's try another synthetic division problem. Ready? Okay, so here we have another polynomial divided by a binomial. So I'm going to start with my half box, and I say, okay, I'm dividing by x minus 1. That's my divisor. The root of x minus 1 is 1. Now my dividend that I'm dividing into is 5x to the 4th plus 7x cubed minus 10x squared plus 4x minus 3. Now I'm going to take those coefficients. I have 5x to the 4th, 7x cubes, negative 10x squareds, 4x's, and my constants are negative 3. Okay, I skip a line, draw my line, bring down the first number 5. Now we multiply. 1 times 5 is 5, add we get 12. 1 times 12 is 12, add we get 2. 1 times 2 is 2, add we get 6. 1 times 6 is 6, add we get 3. So since I started with an x to the 4th, I'm going to have 5x. Now I'm going to have 1 less because I divided by x to the 1st. And x to the 4th divided by x to the 1st, we subtract exponents and get x to the 3rd. So again, my coefficients, 5x to the 3rd plus 12x squared, we decrease each time, plus 2x's plus a constant of 6, plus 3 is my remainder over my divisor x minus 1. And this is the answer to my division. Now, my quotient is the part without the remainder. 5x cubed plus 12x squared plus 2x plus 6. My remainder is 3. But the answer to my division problem was that 5x cubed plus 12x squared plus 2x plus 6 plus the remainder over the divisor. Now again, I have another polynomial that I'd like you to evaluate at. I want you to take that dividend and evaluate this time at 1. So we're going to have 5 times 1 to the 4th plus 7 times 1 to the 3rd minus 10 times 1 squared plus 4 times 1 minus 3. So I have 5 plus 7 minus 10 plus 4 minus 3. So 5 and 4 is 9 plus 7 is 16 minus 13. That gives me 3. So P of 1 is 3. Okay, and again, I'm going to come back to that in a little while. Now, let's look at the next one. Now, here's the problem. We have a polynomial, 2x cubed plus x squared minus 13x plus 6, divided by a binomial, 2x minus 1. That leading coefficient is not 1. That's going to cause a problem for us. Now, I usually find my students have a little easier time if I rewrite this. Since I'm going to have to do some manipulation anyway, I'm going to rewrite this division problem as a fraction. Okay with that? Because fraction is division. Now, the problem is I have that 2 on the bottom. So I'm going to factor out the 2. And if I take 2 out of 2x minus 1, I'm going to get x minus 1/2. Okay? Now, here's the thing. In order to get rid of this 2, I need it to cancel with a 2 up top. That means I need to factor a 2 out of the dividend. So if I factor out a 2, I'm going to have x cubed plus 1/2 x squared minus 13/2 x plus 3. Now, I know you guys are freaking out now because you're seeing lots of fractions. Calm down and trust me. I promise it's not that bad. These 2's are going to cancel out, and now we're going to have our leading coefficient is 1, and we're going to be able to do synthetic division. So now I'm going to set up my half box. My root this time of x minus 1/2 is 1/2. My leading coefficients of my dividend are now 1, 1/2, negative 13/2, and 3. I promise it's not as bad as you're afraid it is. I'm going to bring down the 1. Watch what happens. 1/2 times 1 is 1/2. What's 1/2 plus 1/2? Oh, that's 1. Okay, I can do that. 1/2 times 1, that's 1/2. Now, if I have negative 13/2, I'll write it over here, negative 13/2 plus 1/2. That's negative 12/2, but negative 12/2 is just negative 6, isn't it? And then 1/2 times negative 6 is negative 3, and if I add that up, I get 0. Okay, now we started with an x cubed, so these are the coefficients on a quadratic, okay? Because we started with the cubic, we divided by a linear, we're going to get a quadratic. So I have 1x squared plus 1x minus 6, and I have no remainder. So now let's remember, our divisor was 2x minus 1. Our dividend was 2x cubed plus x squared minus 13x plus 6. Our quotient is x squared plus x minus 6. Our remainder is 0, so our answer to the division is just x squared plus x minus 6. Now I have one more thing I want you to do. I want you to take 1/2 and plug it into our dividend again. So this time we're doing 2 times 1/2 cubed plus 1/2 squared minus 13 times 1/2 plus 6. Now you can whip out a calculator if you want. Or 2 times 1/8 plus 1/4 minus 13/2 plus 6. This is going to give me 1/4 plus 1/4, which is really 1/2, minus 13/2. Now 1/2 minus 13/2, that's the same thing we did up here. That's -6 plus the 6, I get 0. So we just found that p of 1/2 is 0. Now, I want you to look at where I got these from. Okay, in the last few problems. I asked you to do p of 1/2. That was the number in our box. And notice we got the same number as the remainder. Look at the one previously. We did p of 1 equals 3. That 1 was the number in my box, and the 3 was my remainder. Look at the one before this. We did p of -4 equals -2. The -4 was the number in the box, and the -2 was our remainder. So what does that mean for us? What does that mean for us? It means if we take the root of our divisor, which in this case is a, and we plug it into the dividend, p of x, we are going to get the remainder for the division. So the remainder theorem says if a polynomial function f of x is divided by a factor x minus r, then the remainder will be the same value as f of r, because in this case, the root of x minus r is r. And you plug that into the function, and it will give you the value of the remainder. So for instance, if I want to find the remainder when the polynomial p of x is divided by x minus 3, I find p of 3, because 3 minus 3 is 0. That's why I'm using 3. And we're going to plug in 2 times 3 to the third minus 3 times 3 squared plus 2. 3 cubed is 27 times 2 is 54. That's 27 again, plus 2, so we're going to get 27, 28, 29 will be the remainder when we do that division. And that's it. So you don't have to do the whole synthetic division or long division to find the remainder. Now, what if I change the question this time and tell you I want the remainder to be 8, but I have this k that I don't know what it is? All right, so I'm going to divide by x plus 2. So notice x plus 2, the root is -2. So I'm going to find p of -2. If I want the remainder to be 8, then p of -2 has to be 8. So we're going to have -2 times -2 cubed minus 2 times -2 squared plus k times -2 minus 2, and this has to equal 8. Okay, so -2 cubed is -8 times 2 is 16. -2 squared is 4 times -2 is -8 minus 2k minus 2 equals 8. So I'm going to have -10. I'm going to have 6 minus 2k equals 8. Subtract 6 from both sides. -2k equals 2. Divide both sides by the -2, and k is -1. So if we put a -1 in for k, then when we divide by x plus 2, our remainder will be 8. Okay, guys, so we reviewed long division, synthetic division, and we learned the remainder theorem. All right, have a great night. Bye.